Next we shall go for Q lines. Let R vector equal to A1 vector plus SU vector and R vector equal to A2 vector plus TV vector are any two lines, be any two lines. Then box product A2 minus A1 UV. Remember, if this is equal to 0, the lines are intersecting. If it is not equal to 0, then lines are skewed. This implies lines are skewed. If the lines are skewed, then the shortest distance between skew lines is given by the formula. The same box product A2 minus A1 UV. This will give a number, isn't it? Take the modulus of that number and then modulus of U cross V. This is the shortest distance between these two skew lines. So first I must check this determinant, this box product, and if it is not equal to 0, then the lines are skewed. When applying this formula, you can find the shortest distance between these two skew lines. We have only two problems in our exercise. So exercise 6.5, second problem. Show that the lines R vector equal to 6i plus j plus 2k plus s into I plus 2j minus 3k and R vector equal to 3i plus 2j minus 2k plus t into 2i plus 4j minus 5k are skewed and hence find the shortest distance between them. Remember, shortest distance means always the perpendicular distance between two objects. So, from first line, shall I write the vectors and points straightly? A1 vector is 6i plus j plus 2k and U vector is I plus 2j minus 3k. From second line implies A2 vector is 3i plus 2j minus 2k. The vector, the scalar is vector. V vector is 2i plus 4j minus 5k. Therefore, lines are not parallel because U and V are different. So, first we should find A2 minus A1. 3 minus 6 minus 3i. 2 minus 1 plus j minus 2 minus 2 minus 4k. So, we shall find box product of A2 minus A1 UV. Therefore, box product of A2 minus A1 UV equal to, determinant, isn't it? Minus 3 plus 1 minus 4, 1, 2 minus 3, 2, 4 minus 5. This is equal to expanding minus 10, minus 12 means plus 12, minus 1, minus 5, minus 6 means plus 6, minus 4, 4 minus 4. It is minus 3 into 2, minus 1 into 1, minus 4 into 0. It is minus 6 minus 1 minus 0. It is minus 7. See, not equal to 0. Therefore, lines are skewed. If the lines are skewed, then the shortest distance is given by the formula modulus of box product of A2 minus A1 UV by modulus of U cross V. So keep this one as 1. I have box product of A2 minus A1 UV. So it's enough to find only U cross V. So therefore, u cross v is, again cross product means determinant, but here first row is ijk. U is 1, 2, minus 3, v is 2, 4, minus 5. Means I into minus 10 plus 12, minus j into minus 5 plus 6, plus k into 4 minus 4. That is 2i minus j plus 0k is 1 into minus. Therefore, modulus of u cross v is root of 2 square minus 1 the whole square plus 0 square 4 plus 1, it is root 5. Therefore, 1 implies shortest distance is box to modulus of minus 7 by root 5. So the answer is 7 by root 5. This is the shortest distance between these two skew lines. This is all we can do. So first go for the box product. If it is non-zero, then the lines are skewed. If it is zero, the lines are intersecting. So this is problem number 2 in your exercise 6.5. Now we shall go for one more problem. That is problem number 5. Show that the lines x plus 1, very important, minus 12 is it, and x equal to y plus 2 equal to 6 is it minus 6 are skewed, and hence find the point of shortest distance between them. Now, see they gave the line in a different format. So we shall take that one. Given x plus 1 equal to 2y equal to minus 12 is it. I am not having any vectors in the denominator, but make sure that x is coefficient of x is 1, where it is 2 and it is 12, minus 12. We must make it as coefficient as 1. Of these three numbers, 12 is the greatest number, so let me divide by 12. Then this implies x plus 1 by 12, 2y by 12, 2y by 12, minus 12 is by 12. Then this implies x plus 1 by 12. Is it y by 6? Can we write y plus 0 by 6? Then it is plus z by minus 1. So plus z plus 0. So can you identify the points? Therefore, A1 vector is the numerators, isn't it? But here, similarly, let me write the second line. So this is first line. So we can write the points. So A1 equal to minus I, 0j, 0k. And then U vector is 12i plus 6j minus k. Similarly, go for the second line. Given x equal to y plus 2 equal to 6 into z minus 1, isn't it? So when I divide by 6, then it is x by 6, y plus 2 by 6, z minus 1 by 1. So is it not x plus 0 then A2 is 0i minus 2j plus k, and then v vector is 6i plus 6j plus k. From this, what is mass product of A2 minus A1? U, B, or we should find A2 minus A1 first. A2 minus A1. A2 minus A1 minus 1 plus 0 minus I, 0 plus 2 plus 2j, 0 minus 1 minus k. Therefore, box product of A2 minus A1, U, V means determinant, isn't it? It is minus 1 to minus 1, U is 12, 6 minus 1, V is 6, 6, 1. So expanding, minus 1 into 6 plus 6, minus 2 into 12 plus 6, minus 1 into 12 6 are 72 minus 36. It is 12, so minus 12. 80, so minus 36. 72 minus 36 is 36, so it is minus 36. 36, 36, 72, 12, 84. So it is minus 84, not equal to 0. Therefore, lines are skewed. Since the lines are skewed, then the formula between. So we proved the lines are skewed. Therefore, shortest distance is given by the formula modulus of box product of A2 minus A1 UV by modulus of U cross V. We shall keep this one as 1. I have box product of A2 minus A1 UV, so enough to find only U cross V. Therefore, U cross V means again determine IJK. U vector is 12, 6 minus 1, V vector is 6, 6, 1. I into 6 plus 6, 12. Straightly 6 plus 6 minus J into 12 plus 6 plus K into 72 minus 36. It is 12i minus 18J plus 36K. Therefore, modulus of U cross V means it is root of 12 square minus 18 the whole square, 36 square. Remember, 144. 18 square is 18 into 18. 8 8s are 64, 8 1s are 8, 8 plus 6, 144. 84, 12, 3, 324. 36 square means 6 power 4, 216 into 6, 6 6 are 36, 1 6 are 9, 2 6 are 12, 1296. So 1296, 324, 144, 10, 14, remain 1, 10, 16, remain 1, 5, 6, 7, it is root of 1764. So this can be divided by 4. So when I am divided by 4, 4 times, remainder on 16, 4 times, remainder 4, 1 time. Remember 4 is 2 square, 441 is 21 square. So 2 into 21 is the square root 42. Therefore, 1 implies shortest distance is modulus of minus 84 by 42. It is modulus of minus 2, it is 2 units. So this is the shortest distance between these two lines. So we proved this determinant is not equal to 0, therefore the lines are skewed. We applied in the formula. We got U cross V as 42. When we substitute, minus 84 by 42 is minus 2, but I must take only the modulus value, so plus 2, that is the positive value. That gives the shortest distance. With that, shortest distance between the skew lines is over, and also study of skew lines is over. Next we are going to study something about connection between two lines if they intersect and if they pass through some other point, either parallel or perpendicular vectors if they have, then how to find the equation of that line. That we are going to study. So that is our next concept. Now we shall go for problems related to properties of straight line, that is using skew lines, point of intersection. We are going to study some more things. Find the equation of straight line passing through the point of intersection of these two lines and perpendicular to both the straight lines. So a straight line is passing through the point of intersection of these two lines and it is perpendicular to both lines. That I have to find out. So first we shall find what is the point and vector. So let me take as the first line as given. First line is R vector equal to I plus 3j minus k plus t into 2i plus 3j plus 2k. If you are not able to write or to find out the point straightly, we shall write in Cartesian form, that is x minus 1 equal to y minus 3 equal to z plus 1 by 2 by 3 by 2, and we shall keep this one as s. Then point is it not 2s plus 1, 3s plus 3, 2s minus 1, This is the point on the first line. Now, second line is, they gave us x minus 2 by 1, y minus 4 by 2, z plus 3 by 4 equal to t. Then, point is, t plus 2, 2t plus 4, 4t minus 3. Since these two lines are intersecting, these points must be equal. Then this implies 2s plus 1, 3s plus 3, 2s minus 1 equal to t plus 2, 2t plus 4, 4t minus 3. Equating any 2 points, 2s plus 1 equal to t plus 2, 2s minus t equal to 2 minus 1, 2s minus t equal to 1. This is one equation. Similarly, 2s minus 1 equal to 4t minus 3, 2s minus 4t is minus 3 plus 1. I can take any 2 lines, any 2 points. So 2s minus 4t equal to minus 2. We shall solve these two equations. 2s minus 4t equal to minus 2. 2s minus t equal to 1. Minus, plus, minus. 2s cancels. Minus 3t equal to minus 3t equal to 1. Don't need to find out s. If I substitute t as well, I will get the point. Therefore, point is when t equal to 1. Point is 1 plus 2, comma 2 plus 4, comma 4 minus 3. That is equal to 3, comma 6, comma 1. This is the point. Now, I got a point. Now I need a vector. For that they give the line is perpendicular to both the straight lines. So, here the vector in the first line is 2i plus 3j plus 2k, and the second vector is, that is, from the lines. Can we write the vector straightly from the straight lines? U vector equal to straightly 2i plus 3j plus 2k. Parallel vectors we shall know. And v vector equal to the numbers in the denominator, isn't it? I plus 2j plus 4k. These are the vectors. Any line perpendicular means the vector will be perpendicular to both u and v means, then the perpendicular vector, then perpendicular vector to both u and v, shall we keep it as w, is u cross v, isn't it? Cross product gives me always perpendicular vector. So if I keep it as w, then that one is u cross v. Therefore, there also we shall keep the point as equal to c. That is, vector c equal to 3i plus 6j plus k. This is the point, and the vector is w. So w equal to, but we know cross product means determinant, isn't it? U is 2, 3, 2, v is 1, 2, 4. Therefore, w equal to I into 12 minus 4 minus j into 8 minus 2 plus k into 4 minus 3. It is 8i minus 6j plus k. Therefore, equation of straight line passing through point C of 3, 6, 1 and parallel vector w equal to 8i minus 6j plus k is r vector equal to 3i plus c vector plus t is some other m into w vector. So r vector equal to 3i plus 6j plus k plus some m into 8i. We can use any letter, any vector, and we used to get always ABC as points and UVW as vectors. Also I can take the Cartesian form. Cartesian equation is x minus 3, y minus 6, z minus 1, by 8, by minus 6, by 1. This is the Cartesian equation. Like this we can find. So first find the point of intersection, then find the perpendicular vector. You must know what are the vectors, you must find out the vectors, and if you find cross product you get the perpendicular vector. You keep that one as W and the found at the point as C, then R vector equal to C vector plus MW vector. That gives the vector equation. Therefore the answer is R equal to 3i plus 6j plus k, which is M into 8i minus 6j plus k. This is, for example, 6.34. We did example 3.36. 3.7 we have to do. Before that, I will complete all the exercise problems and come back to the last example. Now, exercise 6.5. First problem. Find the parametric form of vector equation and Cartesian equation of a straight line passing through 5, 2, 8 and perpendicular to the straight line R vector equal to I plus j plus k, j minus k plus s into 2i minus 2j plus k and R vector equal to 2i minus j minus 3k plus t into I plus 2j plus 2k. Therefore, I have to find out the equation of a straight line passing through this point and perpendicular to these two lines. We know how to do from our example. So, given line passes through point 5, 2, 8. So, shall I keep it as some a vector equal to 5i plus 2j plus 8k. Now, given be the point. Now, given line is perpendicular to R vector equal to I plus j minus k plus s into 2i minus 2j plus k and another line R vector equal to 2i minus j minus 3k plus t into I plus 2j plus 2k. Since I have to find out the perpendicular vector, let me collect only the vectors. So vector in the first line is therefore parallel vector from first line u vector equal to 2i minus 2j plus k. The vector coming with the scalar is the vector. So parallel vector from second line is v vector equal to I plus 2j plus 2k. Therefore, perpendicular vector means perpendicular vector to both u vector and v vector. W vector is u cross v vector. So W equal to cross product means determinant ijk. U vector is 2 minus 2 1 1 2 2. So it is I into minus 4 minus 2 minus j into 4 minus 1 plus k into 4 plus 2. It is minus 6i 3, so minus 3j plus 6k. Therefore, vector equation passing through a vector equal to passing through, better mention point passing through point A vector equal to 5i plus 2j plus 8k and parallel to W vector equal to minus 6i minus 3j plus 6k. Equation R vector equal to A vector plus some other MW vector. That is 5i plus 2j plus 8k plus m into minus 6i minus 3j plus 6k. This is your vector equation, and therefore Cartesian equation is x minus 5 y minus 2 z minus 8 y minus 6 y minus 3 by 6. This is the Cartesian form. So this is the first problem. So whenever you are asked to find out perpendicular means, you must find the first vector and the second vector, and you must find the cross product. Cross product gives the perpendicular vector. So this idea you must have in your mind. Now, I did problem number 1. Then I have to go for problem number 6 now. Then 7, then one more example. Now 6th problem. Find the parametric equation form of vector equation of a straight line passing through minus 1, 2, 1 and parallel to the straight line R vector equal to 2i plus 3j minus k plus t into I minus 2j plus k, and hence find the shortest distance between them. Are you able to follow this problem? There is a line passing through this point and parallel to this line. I have to find that line. After finding that line, I must find the distance of that line with this line. So let me take this one as the given line. So given R vector equal to 2i plus 3j minus k plus t into I minus 2j plus k. We shall keep this one as 1. And I am in need of parallel, therefore parallel vector B equal to RU equal to I minus 2j plus k. So this is the vector. Now therefore the equation of line passing through minus 1, 2, 1 and parallel to I minus 2j plus k. Then vector equation is R vector equal to this B vector plus some SU vector. That is R vector equal to minus I plus 2j plus k plus S into I minus 2j plus k vector. So this is the parallel line. Now from this, shall we find A1, A2, U? Since the lines are parallel, U vector is the same. Therefore, A1 vector is, or A vector is, since I used B, let me give this one as A, is 2i plus 3j minus k, and B is, from here, it is minus I plus 2j plus k vector. These two are points, and then U vector is I minus 2j plus k vector. This is our u vector. So I am in need of b minus a. Minus I minus 2 minus 3i. 2 minus 3 minus j, k plus k, 2k vector. Then remember, since the lines are parallel, shortest distance between parallel lines is given by the formula. For the formula, b minus a cross u by modulus of u, the modulus shall be this one as 1. So we shall find b minus a cross u vector. B minus a cross u vector means determine, that is I, j, k. B minus a is minus 3 minus 1 2. U vector is 1 minus 2 1. It is I into minus 1 plus 4 minus j into minus 3 minus 2 plus k into 6 plus 1 minus 1 plus 4. It is 3i minus into minus plus 5j plus 7k. I am in need of modulus of b minus a cross u vector is root of 3 square 5 square plus 7 square. So we shall write here. So it is equal to b minus a cross u vector modulus is root of 9 plus 25 plus 49. 49, 58, 25, 13 remain 1, 83, root 83. And therefore, modulus of modulus of u is root of 1 square minus 2 the whole square plus 1 square. It is 1 plus 4 plus 1, it is root 6. Therefore, we kept already 1 and 2, so we should keep that one as 3. Therefore, 3 implies shortest distance is root 83 by root 6 or root of 83 by 6. You can leave it as this is the shortest distance between these two lines. This is your sixth problem, another important problem. Now we shall go for the most important problem, seventh problem. After completing seventh problem, I will go for one example, exactly the same of seventh problem. Now, next, seventh problem. Find the foot of perpendicular from a point five comma 4 comma 2 to the line x plus 1 by 2 equal to y minus 3 by 2, 3 equal to z minus 1 by minus 1. Also, find the equation of the perpendicular. Now listen here, you must understand the word foot of perpendicular. For any line, if I have a perpendicular line, it is just a perpendicular line. But suppose there is a line from a particular point A, we need a perpendicular means, then it is foot of perpendicular. So, from a particular point, I need a perpendicular line to a line, and then it is known as foot of perpendicular. Therefore, perpendicular is different from foot of perpendicular. From a point to a line, if I have a perpendicular line, then that one is called a foot of perpendicular. So, take that point as D. Let D equal to 540. And even straight line is x plus 1 by 2 equal to y minus 3 by 3 equal to z minus 1 by minus 1. So this is the straight line AB. Straight line AB is, then D is somewhere here. What is that? 5, 4, 2. So I need a perpendicular. This F is the perpendicular. So let me find this point F. That is our ultimate thing. So let me find this F. Listen here. This F is in AB, isn't it? Therefore, this implies x plus 1 by 2 equal to y minus 3 by 3 equal to z minus 1 by minus 1. Suppose if I take it as t, then point equal to 2t minus 1, 3t plus 3 minus t plus 1. Therefore, this is our point F vector, that is OF vector is 2t minus 1 into I plus 3t plus 3 into j. Let me write in vector formation, minus t plus 1 into k vector. This is our OF vector. Therefore, we shall find FD vector. FD vector means OD vector minus OF vector. OD is 5i minus plus 4j plus 2k minus OF vector is 2t minus 1 into I plus 3t plus 3 into j plus minus t plus 1 into k. This is our OD. Okay, subtract means 5 minus 2t minus 1 into I, 4 minus 3t plus 3 into j, 2 minus t plus 1 into k. Update the 5 minus 2t plus 1 into I, 4 minus 3t minus 3 into j, 2 plus t minus into k. It is 6 minus 2t into I. 4 minus 3 is 1 minus 3t into j. 2 minus 1 is 1 plus t into k. This is our FD vector. So this is FD vector. But we know from the line AB, U vector is the numbers in the denominator, isn't it? That is 2i plus 3j minus k. Before writing, ensure that xy is a coefficient for 1. Now, this is the vector parallel to AB. So that means this FD vector and U vector will be perpendicular. That means this implies FD vector is perpendicular to U vector. Then this implies dot product between these two vectors will be 0. So, what is FD? 6 minus 2t into I, 1 minus 3t into j, 1 minus 3t plus 1 plus t into k dot 2i plus 3j minus k equal to 0. Dot product means 2 into 6 minus 2t plus 3 into 1 minus 3t minus 1 into 1 plus t equal to 0. That is 12 minus 4t plus 3 minus 9t minus 1 minus t equal to 0. It is minus 4 minus 9 minus 3 is minus 14t. 15 minus 1 is plus 14 equal to 0. Minus 14t equal to minus 14, t equal to 1 straightly. When I substitute t equal to 1, then FD vector equal to, I am in need of OF only, so we shall find OF vector. OF vector equal to 2 minus 1 into I, substituting t as 1, 3 into 1 plus j minus 1 plus 1 into k, where t equal to 1. then OF vector is I plus 6j plus 0k. Now I have to find out this equation. Therefore, equation of theta perpendicular FD passing through. D is 5, 4, 2 and F is 1, 6, 0. 2 points are there, then R vector equal to some other C vector plus M into D minus C vector, isn't it? So R vector equal to 5i plus 4j plus 2k plus M into 1 minus 4 minus 4i, 6 minus 4, 2j minus 2k. Or I can give vector form. This is the vector equation. Cartesian form also we can give. That is x minus 5, y minus 4, z minus 2, y minus 4, y 2, y minus 2. What is this? This is the Cartesian equation. So, like this we can find the seventh problem. X minus 5, y minus 4, y minus 4, y 2 equal to z minus 2. So, this is very important problem. Problem number 7. I am having one more example. We shall do that examples also. Now, a similar problem. Example 6.37. Another important problem. Find the coordinates of theta perpendicular from the point minus 1, 2, 3 to the straight line R vector equal to I minus 4j plus 3k plus t into 2y plus 3j plus k. Also find the shortest distance between these 2 points from the point to the straight line. Now we shall take the line AB as this. D is a point that is minus 1, 2, 3. From this point, a perpendicular distance is drawn. That is called theta perpendicular. We shall give that point as F. Let D equal to minus 1, 2, 3. Let given line ABB R vector equal to I minus 4j plus 3k plus t into 2y plus 3j plus k. Therefore, here this implies u vector is 2y because I am not interested, I am not in need of a point. So this is u vector. And let me write in Cartesian form. And then the Cartesian equation is AB implies straightly x minus 1, y plus 4, z minus 3, y2, y3, y1. And if I take this one as t, then point is 2t plus 1, 3t minus 4, t plus 3. This is the point F. Therefore, OF vector equal to 2t plus 1 into I, 3t minus 4 into j, t plus 3 into k. So let me find this vector, FT vector. Therefore, FT vector, because I am in need of this point V, point here, so I have to find out this t. So let me find this point or this vector FT. FT is what? OD vector minus OF vector. OD is minus I plus 2j plus 3k minus 2t plus 1 into I, 3t minus 4 into j, t plus 3 into k. Therefore, this implies the numbers are minus 1 minus 2t plus 1 into I, 2 minus 3t minus 4 into j plus 3 minus t plus 3 into k. It is minus 1 minus 2t minus 1 into I, 2 minus 3t plus 4 into j, 3 minus t minus 3 into k. It is minus 2 minus 2t into I, 6 minus 3t into j. 3 minus 3 cancels, minus tk. This is ft vector. So this is ft vector. Then ft vector will be perpendicular to the parallel vector AB, and this is the parallel vector. Therefore, ft vector and u vector are perpendicular. So this implies ft vector is perpendicular to u vector. U vector is parallel to AB vector. So if this df is perpendicular to AB means it's perpendicular to u also. That means ft vector dot u vector equal to 0. Dot product between these two. So we write straightly 2 into minus 2 minus 2t plus 3 into 6 minus 3t plus 1 into minus t equal to 0. It is minus 4 minus 4t, 18 minus 90 minus t equal to 0. Minus 4 minus 9 minus 1 is minus 14t, 18 minus 4 is 14 equal to 0. Minus 14t equal to minus 14, t equal to 1. Therefore, f vector is, or OF vector is, here I have this OF vector. So from this let me find the point f, that is 2 into 1, 2 1 20 equal to 1. 2 plus 1 into I, 3 minus 4 into j, 1 plus 3 into k. It is 3i minus j plus 4k vector. So I am having OF and OD. Therefore, this is OF vector. Therefore, OD vector is minus I. Not nursery. Now I found OF vector, that's all. Now what they are asking? They are asking the distance between OF and F and D. So that is, I have to find the FD vector. Shortest distance between F and D is modulus of FD vector, because just the distance between these 2 points only. That is, FD vector means OD vector minus OF vector. OD is modulus of minus 1, 2, 3 minus OF is 3 minus 1, 4. Let me write in IJK format. It is minus 1 minus 3 minus 4i, 2 minus 1, 3i, 3j, 3 minus 4 minus k. Modulus means root of minus 4 the whole square, 3 square, minus 1 the whole square. It is 16 plus 9 plus 1. It is root 26. This is the shortest distance between these 2 points. So with that, we finish this problem. With that, exercise 6.5 is over. You shall see 6.6 in the next class.